Okay, good morning students. Today we will see the continuation for the one is nothing but inversion configuration. Okay, yesterday we see about retention of configuration, and today we will discuss about inversion of configuration. What is the meaning of this one? For example, you take one alkyl halide and take. For example, you take like hydrogen and hydrogen and hydrogen. It is alkyl halide. It is attacked with a nucleophile OH minus. Yesterday we see retention. What is the meaning of retention? Okay, from which side leaving group is coming outside, from the same side attacking species introducing. Then we are getting retention configuration. But now we are discussing about the inversion of configuration. When? So whenever newly incoming particle is unable to approach from the same side to the leaving group, then what happening? This attacking or newly introducing particle will be approaching the reacting space from the opposite side to the leaving group. From the same side to the leaving group, retention. From the opposite side to the leaving group is called as inversional structure. Then what we are getting, OH will be coming this side. After approaching like this, what happening, in between OH group and hydrogen atom repulsion will start. Then what happening? To minimize the repulsions, these all groups move away from that OH group. That's why the H particle will be coming opposite side to OH group. So this is called as inversion of configuration. Means the newly introducing particle is approaching from the opposite side to the leaving group. This is the leaving group. Okay, with respect to that leaving group, newly incoming particle is approaching in the opposite direction. So then it is calling as an inversional structure. So it is also calling with one name. It is nothing but Walton inversion. Why? Means this is means identified by Walton scientist. He compared with one good example. If you take umbrella, yes, okay, umbrella will be like this. So reactant will be having like this structure. Means after reaction, getting product will be quite opposite. How it is that one? You take umbrella, keeping strong wind. What happening? That cloth will be going that side. It's almost means whatever arrangement will be here, that cloth will be going in opposite direction. Means the handle will be like this and cloth will be like this. This is calling as inversion. So what is the concept here? If taking reactant is D isomer, getting product will be L isomer. No, you are taking reactant is L isomer, getting product will be D isomer. Inversion, quite opposite is going on. All of it clear? Yes, this is the information regarding inversion of configuration. Now, based on these all things, we are discussing one of the farmer's question. What is that one? I will explain you. See carefully. Farmer's question you are learning. So, what is the farmer's question? Is nothing but a nucleophilic substitutional reactions. Nucleophilic substitutional reactions. Very nice concept. If you know all these basics, it is nothing for you. Substitutional reaction. Substitutional reactions. Very carefully you have to observe. You take alkyl halide. Okay, now that alkyl halide will be involving in the reaction with the which one? Either aqueous NaOH or aqueous KOH. What happened? First chemical property of alkyl halide. We are getting alcohols. We are getting. Anyway, this mechanism or the entire process is going through a nucleophilic substitutional reaction. Whenever alkyl halide will be treated with aqueous NaOH or KOH, we are getting alcohol. This entire process will be going through a nucleophilic substitutional reaction. But the nucleophilic substitutional reactions will be having two types of mechanism based on nature of alkyl halide. That is only our important farmer's question. Based on type of or otherwise based on nature of alkyl halide. based on nature of alkyl halide, the nucleophilic substitution reaction mechanism is going in two ways. That two ways only is important for the board examination. Under this first one, it is nothing but SN1 mechanism. SN1 mechanism. I will explain briefly regarding that one. Second one is nothing but SN2 mechanism. SN2 mechanism. Anyway, while converting alkyl halide into alcohol with the aqueous NaOH or KOH, it is going through nucleophilic substitution reaction. Based on nature of alkyl halide, the mechanism is of two types. One is SN1 mechanism, another one is SN2 mechanism. First of all, I will explain about the SN2 mechanism. Okay, first finance question. It is nothing but the SN2 mechanism. Okay, directly you will ask the question. Explain the SN2 mechanism by taking one suitable example. Otherwise, you may ask the question. Explain how methyl chloride will be reacted with the aqueous NaOH. What we are getting? Methyl alcohol we are getting. Same question he may ask in two ways. Explain the mechanism of SN2, or otherwise explain the mechanism how methyl chloride will be converting into methanol or methyl alcohol. Okay, observe very carefully. First of all, what is the meaning of SN2 full form? 2 means what? Bi. Molecular. Bimolecular. N means what? Nucleophile. So bimolecular, nucleophilic. S means substitutional reactions. Substitutional reaction. Nucleophilic, bimolecular, nucleophilic substitutional reaction. That is the meaning. 2 means bi, N means nucleophilic, S means substitutional reaction. That's calling as SN2 reaction. Okay, we will discuss what has to be read as it is read in the examination point of view. First point I am telling this SN2 mechanism going in only one step. This SN2 mechanism going in one step. What alkyl halide you are taking? Methyl chloride reacted with aqueous NaOH. How we are getting methanol? We have to explain all these things. First of all, what happening? Aqueous NaOH or KOH will be there. How it will be decomposing? It's becoming like Na plus OH minus. What is the special of this OH minus? OH minus is acting as a nucleophile. Is it clear? Yes. Now, how it is attacked with the methyl chloride? You have to see very carefully. Yes, you see carefully. See on this H and H and H and Cl bond is there. You know very well between carbon and chlorine partial means unequal shading is going on. That's why it is getting partially negative. This is getting partially positive. Enough to start the reaction. Why? In the alkyl halide, carbon carries a positive charge. It is favorable for attacking of negatively charged particle. That's why it is attacked by which particle? OH minus. I am asking one question. Is it approaching in the same direction to the leaving group, or is it approaching from the opposite side to the leaving group? Opposite side. Why? Approaching particle is negative. Already the leaving particle is also negative. They should not approach together. Means the new incoming particle will not approach it from the same side to the leaving group. Why? Both are like charged particle always repel together. Then what happening? OH minus particle will be approaching from the opposite side to the leaving group. Then automatically we are getting one of the intermediate. We are getting, how to see carefully. Carbon. On this what will be there? Hydrogens will be there. Are you getting or no? Whenever OH minus will be attacking, what will happening? CCl bond will becoming weak. Means it is denoted by dots. Meaning is slowly becoming weak. Means almost breaking. Okay, what happening here while attacking? Here which particle is coming? The OH particle will be coming. So this is only we are calling as intermediate. Intermediate. What is the meaning of intermediate? In the middle of the reaction, it will be forming and it will be consuming. So, and one more thing I am telling, this intermediate is highly unstable. Why? Yes, check it carefully. This carbon atom actually should get 4 bonds, but here partially how many bonds will be there? 5 bonds will be there. So crossing its valence is dangerous. Okay, that's fine. This intermediate is highly unstable particle. Unstable means what happening? Becoming stable by breaking something or by doing something. So then what happening? Finally, this total bond will be breakdown and this bond will becoming strong. Then it's maintaining 4 valency. Then what we are getting? Carbon will has strong bond with OH. After that, hydrogens will be coming like this. Which particle is coming outside? Cl minus plus Cl minus is coming outside. Again, this Cl minus will be combined with N+, is not important for us now. So, are you getting on? So, in case of SN2 mechanism, it is going in only one step. First point, SN2 mechanism going in one step. Okay, first of all, NaOH will be split down into ions, then it is producing nucleophile. That nucleophile will be attacking on the alkyl halide from the back side or opposite side to the leaving group. Why? Plus we can explain so many things. This leaving group is also carrying negative charge. This attacking particle is also carrying negative charge. The spine should not approach in the same direction. The spine, it will be attacking from the opposite side to the leaving group. Then we are getting one of the intermediate. It will be highly unstable. Highly unstable means within fraction of seconds it will be forming and decomposing. Why? In this intermediate, carbon gets 5 bonds, should not. Then what happens? The leaving groups totally bond will be breaks, and which is attaching that will be forms. It will become strong, it will become weak or breakdown. Then we are getting like this. So what do you want? Alcohol involved. Okay, we have to explain some important things here. We have to take one important thing: rate of reaction. Rate of reaction. You studied in first year and equilibrium. What is the meaning of rate of reaction? Indirectly, speed of reaction. For our convenience purpose, we are considering it is nothing but speed of reaction. Denoted by letter small r. Rate of forward reaction, rate of backward reaction. Rate of reaction is directly proportional to which one according to law of mass action. Yes, you have lot of energy, then your speed of running will be high. You have low energy, then your running speed will be less. So, overall rate of reaction or speed of reaction is directly proportional to concentrations of the reactant. That is calling as law of mass action. I am writing here, see carefully. Okay, we discussed already this concept in chemical equilibrium. According to law of mass action, rate of reaction is directly proportional to concentration of reactants. That concentration can be represented by writing a square bracket. Okay, now in this SN2 mechanism, the whole reaction is depends upon which one? Concentration of the reactant. What is the concentration of the reactant? It is directly proportional to concentration of the which one? Alkyl halide. While writing, what should be done? Whatever coefficient is there will come in its powers as it is. Do you remember or not? Yes. And what is the another reactant here? It is nothing but nucleophile. Its power will come 1. Why? Because coefficient is 1 goes in its powers. Okay, now I want to do something. I want to write down R is equals to. I want to write equals to this. I want to multiply with one constant K into R alkyl halide power 1 concentration of the nucleophile power 1. This equation only we are calling as rate law. Actually, this concept will come in second year under third topic. Chemical kinetics. This is calling as rate equation or rate law. Rate equation or rate law. Okay, here one word you have to learn. What is that word means? It is nothing but order. Okay, this is the first point, useful point. Second one, order of the reaction. Okay, order means in the rate equation sum of powers of reactants. Sum of powers of reactants in the rate equation is calling as order. Okay, you see here order in this reaction is equals to what is the powers of the reactants? 1 and 1. Nothing but 1 plus 1 is coming 2. What is the meaning of this one?
It is the second order reaction. Second order reaction. Did you got my point? In the rate equation, sum of the powers of the reactant terms only we are calling as order. Order will be 2. That's why it is calling as second order reaction. The whole reaction speed depending upon both alkyl halide as well as nucleophile. It is depending upon how many molecules? 2 molecules. That's why it is calling as bimolecular reaction. Means the whole reaction is depending upon 2 types of the particle. One is alkyl halide, another one is nucleophile. That only right. Rate of reaction is depends on both alkyl halide and also nucleophile. That's why how many types of molecules? 2 molecules. That's why it is calling as bimolecular reaction. That's why SN2 mechanism is calling as bimolecular reaction. Are you clear? Still I have to explain some important things before that. You have to see once again. So up to this one all of you understood, I think. So according to law of mass action, in every chemical reaction, speed of the reaction is directly proportional to concentration of the reactant. In this reactant is what? One is alkyl halide, another one is nucleophile. So according to law of mass action, all is directly proportional to Rx, coefficient with both its powers, coefficient with both its powers. I want you to know the proportionality should multiply with some constant. The whole is calling as rate equation or rate law. We will discuss in chemical kinetics. Don't worry, the brief information we will have to see. So according to chemical kinetics, order means what? Sum of the powers of the reactants in rate equation is calling as order. So what is this one? 1 plus 1, nothing but 2. That's what is calling as a second order reaction. So the whole reaction speed is depending upon alkyl halide as well as nucleophile. That's why it is depending upon 2 molecule information. That's what it is calling as bimolecular reaction. Okay, some other characteristics I am telling here. See very carefully. Next point we have to write down. Is it requires strong nucleophile or weak nucleophile? See carefully. The SN2 mechanism is requires a strong nucleophile or weak nucleophile. Strong nucleophile. Why? If there is no nucleophile, what happening? There is no reaction. The total reaction is initiated by nucleophile. That's why the nucleophile should be strong. That's why SN2 mechanism is possible when involving nucleophile should be strong. Strong nucleophile is requires. Nucleophile is requires. And I am asking one more question. This whole mechanism is requires polar solvent or non-polar solvent. Everything is very important. Okay, now we are taking alkyl halide. Is it undergoing ionization? Is it predominant to ions? No. Means alkyl halide is not involving in the ionization. No ionization. No ionization means polar solvent is not required. That's why SN2 mechanism is worked out even with less polar solvent. If you want ionization, we should use polar solvent. Okay, why? Because this is having polarity. Polarity means polar compound dissolved in polar, but here not requires ionization. That's why not requires polarity. That's why less polar solvent is also worked out. All of you getting? Yes. Okay. SN2 mechanism is required strong nucleophile, and here no ionization is required. That's why even less polar solvent is also useful. And we have to observe one more special character of this mechanism. We are getting retention structures, inversion structures, inversion. Why? Because attacking nucleophile from the opposite side to the leaving group. Then what happening? Water inversion is happening. Umbrella is like this, but here what happening? Cloud will be going outside. So that's why what structures we are getting? Inversion structures we are getting. Inversion structures we are getting. He asks the question like this only. Inversion structures we are getting. Next question. Under SN2 mechanism, are we getting optically active isomer or inactive isomers we are getting? You have to see. For this, I am taking, what is the condition for optical isomerism? Should contain chiral carbon, should not having a plane of symmetry. For this, I am telling, see carefully, here H, here CH3, here C2H5 is reacted with chlorine. Is it having chiral carbon? Yes. Why? This carbon has chlorine, hydrogen, methyl, ethyl. All four groups are different. That's why this is calling as a chiral carbon. Okay, no plane of symmetry, no chance for that. Then it is attacked with which particle? OH minus particle from same side or opposite side? From the opposite side. Then what will be happening? We are getting intermediate stage. We are getting after intermediate, the compound will be decomposing. The total chlorine will be coming outside. After that, what we are getting? OH is coming this side, and here H, here CH3, here C2H5. It is also chiral carbon. Yes. Now my question: under SN2 mechanism, if taking alkyl halide having chiral carbon, we are getting racemic mixture or enantiomers. We are getting enantiomers. Why? Because if you are taking an isomer is nothing but which one? D isomer. Getting isomers will be what? L isomers. Are you getting one? No, you are taking L isomer. Getting product will be D isomer. Anyway, we are getting either D isomers or L isomers. We are getting D or L, which is nothing but optically active compound. That's why under SN2 mechanism we are getting optical active products. We are getting optically active products. We are getting. Are you got my point, all of you? Yes. So you are taking the completely converting into L anyway. Through this you are sending the plane pulsar light. What happening? The plane pulsar light will be deviated in the anti-clockwise direction. That's calling as rotating compound. No, you are getting D isomer. Through the D isomer mixture you are sending plane pulsar light. Then what happening? Plane pulsar light will be deviating in clockwise direction. Anyway, the taking compound having some rotation with respect to plane pulsar light. That's why it is calling as optically active compound. One more important point, what is the reactivity order? Reactivity order of alkyl halide. Very important for competitive. Reactivity order of alkyl halide for which one? SN2 mechanism. Okay, I will give you different types of alkyl halide. You have to tell me about the answer for that. First of all, I am taking C, H, and HCl. First compound. And I am taking one more CH3, C, H, and Cl. Another one is CH3, C, CH3, H, Cl. Another one is CH3, C, CH3, CH3, Cl. All are same kind of alkyl halide now. It is methyl chloride. Okay, it is also nothing but primary alkyl halide. Why? Halogen having carbon attached carbon directly connected with either one carbon or no carbon connection is calling as a primary. It is also halogen attached carbon directly connected with only one carbon. That's why it is also primary alkyl halide. Now halogen attached carbon directly connected with two carbon. That's why it is the secondary alkyl halide. This is the tertiary alkyl halide. My question: among four these alkyl halide, which is more favorable for the SN2 mechanism? Observe the mechanism, you will get the answer. Which one? Yes, what is happening here? The entire things will be going while attacking of OH minus from the backside to the label. You check it in the first compound. Okay, with respect to chlorine, these are back bonds. But here, bonded atoms is nothing but hydrogen atoms. Hydrogen atoms means what? Very small size. Whenever very small size, large empty space will be here. Large empty space will be there. Then attacking of nucleophile OH minus will be easy or no? Easy. Compare with this one here. One bulky group is there. Almost backside area is covered. Then attacking of nucleophile is not that much easy as like first one. Now you comes to here. Backside what happening? Two bulky groups were there. Because of two bulky groups, available empty space from the backside will be less. Attacking nucleophile will be very difficult. You comes here almost backside area is closed. Then attacking of nucleophile OH minus will be almost impossible. That's why which is more favorable for the SN2 mechanism? Right? And that is only it is nothing but methyl chloride is more reactive than which one? Primary alkyl halide than secondary alkyl halide and least this is nothing but the tertiary alkyl halide. You got my concept? The whole thing is related to attacking of nucleophile from the back side. Where available empty space is more, their reactivity will be high. Where backside empty space will be very less. No chance for attacking. No chance for attacking means no reaction. No reaction means reaction speed will be less. If you write like this, you are getting 5 marks. And see, so many important points is coming. We have to explain as this. All of you getting or no? Yes.